Okay, so while you're in third period, I decided to make a video for this because Zoom wasn't working well third period, and I was afraid that when we started fourth period, I wouldn't be able to introduce the lab to you. Not that it requires a lot, but I just did want to take a couple minutes to describe what it is. So you might remember at the beginning of second period today, I showed you what's called an Atwood's machine, with just a freely spinning pulley with a string going over it and a couple of masses that move. So that's what you'll find here in the file. This is already on Google Classroom now. And they come in different varieties. Here's the three that you'll tend to see. The one that I used today in second period is here on the left. The one we're going to use today in this virtual lab is over here on the right, and then there's this one here in the middle that we might end up doing something with. They definitely make good physics problems. In the lab, at school, we have the ability to build these things with the little tracks that we have, and we have inclined them before, but I just found a virtual version of one, kind of played with it a little bit. So you'll open this link here to what's called ophysics.com, tell you what settings to use, and then you're just going to take some data. Basically, what you're looking at here is, as you change the masses, on this one, as you change the masses on these, the system will accelerate differently. Okay, so I call it the system because it's really the combination of M1 and M2 that are moving together. I mean, they're stuck together with a string, so they have to have the same acceleration. And so usually we call that a system. When we have two different parts of that are accelerating in the same way because they're somehow coupled together, so that's referred to as a system. And the pulley wheel here is, we'll pretend, is really light. It doesn't take a lot of effort to move it. I mentioned earlier today in chapter 12, we're going to have these massive pulleys, and it's going to actually take a little bit of force just to get those things to rotate, and that adds another little dimension to the whole thing, but we're not ready for that yet. So I've already created the data tables for you. I've told you the mass combinations that I wanted you to use, and this takes away a lot of the really, I think, important part that I would typically let students figure out on their own, kind of through trial and error and conversations that we have in the classroom, but I didn't know that there was any good way to do that. So I've kind of done it for you. So you just have to fill in a couple of columns here, and then you're going to do another set here. And the only difference is on the first set, you're going to change both the hanging mass and the mass on the table. As one goes up, the other will go down by the same amount. And then on the second set, you're going to keep the hanging mass, the one over the table, the same, but the one on the table is going to increase. And then that's all I had intended for you to have to be done with today. If you want to move on, that's fine. I do have a second part that you'll be doing for the following week during Monday's class. And so you can move on. This is just plotting that data in Desmos and then kind of deciding what kind of graph that you see there. So if you want to move along that far, I will tell you, this is actually the part of the lab I'm happiest with. It's the very last page. I've needed to make this forever because a lot of students, they'll see a graph and they'll be like, oh, I know what that graph is. It looks just like this. Because there's a lot of graphs that look really similar to each other. And then I'll be like, no, that's not quite it. So what I did is I went into Desmos and I plotted about, I think there's almost a dozen different graphs here. And I took some pictures, although they didn't come out great. They're a little light is all. So, and I tried to describe some of the differences between the ones that look real similar. For example, a parabola looks a lot like exponential growth, but it also looks a lot like part of a sine curve. So how do you know which is which? Sometimes you have to explore a little bit more data to figure out what exactly you have. Now on this lab, these are pretty simple relationships. And in fact, in this lab, you already should know what the relationships are because they're really part of Newton's second law. But we're just kind of imagining here that we're discovering something new and we're trying to figure it out based on the data that you collect. Okay. So that second part, again, my plan is to have you do that during class on Monday. So it'll be finished up by Thursday the 10th, okay? Because there is going to be a second part to this. But I did get smart this time, and this part you can turn in, and it'll be just called Part 1 of the Atwood's Machine Lab. And then I'll have a separate assignment, Part 2, because a lot of times I have to see how part 1 goes before I know exactly how I want to proceed in part 2. So, we'll see. So anyway, if you're watching this video, we'll assume that Zoom is not working right, and I'm glad you found this. And so if you need anything, like if you want to take a quiz, remember you're allowed to take 1 quiz during this period. Send me an email. I'm still here watching. And we just can't do a live Zoom back and forth. But, we could do some things via email if you have some questions or problems or anything like that. So, okay, we're about 6 minutes, aren't we? So let's wrap this up, and hopefully things go okay for you. Let me know if there's any issues.